everyone, and welcome back to video number 3. That's right, video number 3 in this Bambu Lab Getting Started series. So in the last couple of videos, we looked at some basic controls, some scaling, some arranging, and how to use multiple plates. In this video, we're going to look at changing a few settings to increase 1, your quality, 2, saving some material, and 3, your speeds. So let's jump right into it without any further ado. You can see here we have our friend the Benchy back, and this time we're going to go with a lime green Benchy. I like the lime green Benchy. It makes me think of, I don't know, maybe a nice tropical vacation or something like that. Let's go with that. Alright, so far we've stuck with the default 0.2 millimeter standard profile. Now what does this mean? Well, 0.2 millimeter is the layer height that it's going to slice this Benchy at. So we'll go up here and take a slice of this Benchy. Hey, maybe it's key lime pie Benchy. So you can look here, and you can see these lines. They're a little difficult to see, and that's okay, because we're at the 0.2 millimeter layer height. I'm going to go up here and change this color scheme from line types so we don't see all these different types. I'm going to change it to layer height, so you can kind of see it's kind of matched up here. This 0.2 is matching up with the orange look of the layers here. So what we want to do is, if we want to print a little bit faster, let's note that we have a 47-minute Benchy taking about 12 grams. One way to print faster is to increase the layer height, which means that these layers will be thicker, but it will take less time to stack each one upon itself and get to the top. So looking here, there's a whole bunch of different presets you can do. Right now, I'm going to go ahead and click the Extra Draft preset. Pretty much the highest layer height this 0.4 nozzle will give us. And we'll go ahead and give it a slice. Another slice of key lime Benchy. You can see these lines look a little bit thicker, and that's because they are. But you can see we've used a little bit more material. However, we've saved almost 10 minutes off of this Benchy. And that's because the nozzle and the head only have to travel a shorter distance in order to deposit each line. So think of it this way. If you have a lower layer height, each one of these lines has to be stacked upon one another, correct? Well, if you have a thicker layer height, that means there's less stacks that you have to put down in order to get to the top, just like building a wall. Now, what does this mean? This means your quality is going to degrade a little bit. And I say a little bit because it'll be noticeable, but it'll still be a pretty good looking print. The things you're going to run into is, notice up top here, this stair stepping, and on the Benchy hole here, the stair stepping. Because there's less lines in a layer, or less lines overall, it has to stack them pretty high, and there's not a whole lot of room for it to smooth this out. Now let's go to an extra fine detail, 0.08. And let's slice that and see what it looks like. Now you can notice there's a lot more stairs up here on the Benchy, but they're smoother. And you can see the same thing here. There's more on the side, but they're smoother. This is because each layer, and they're almost invisible now, is stacked so thinly it can actually stack more in the X and Y direction in each Z direction. So I know that sounds a little confusing. Let me try and break that up for you. So in the Z direction, there's only so high you can go on the part unless you scale it. So in order to get more detail, you scale down the individual lines, and it's able to put more detail not in just the height, but in the width as well. Another place you can see this is in the Benchy overhangs under here. Notice how there's not very many overhangs. And that's because this little stair step, it's able to only overhang a little bit because the lines are so thin. Conversely, going back to that 0.28 draft layer height, you can see there's bigger overhangs because it can't stack as many steps over in the same height range. Now remember, at extra thick layer heights, we have a 38-minute benchy. Let's go check what that time is for that 0.08 benchy. We've used a little less filament. However, we've more than doubled our printing time. And that's because there's going to be more layers to stack up to get to the finished result. The head has to do more work, and you can see that over here with almost 600 layers. Versus going back to the draft, we're probably going to have less than half. Yeah, we're down to 172. So that's how you can save quite a bit of time. Like I said, there's a few trade-offs. Another trade-off you can look at here is if you have text. At this really thick layer height, you really can't read it. However, if you go down to the extremely fine layer height, you can actually make out most of the text on the 3D Benchy. So there's a trade-off. You have to consider, what do you want? Do you want some speed or do you want some quality? It's a trade-off. For most draft parts, and that's why it's called a draft profile, you can get away with it because you're just prototyping, and maybe it just needs to work and not look super pretty. Maybe you're going to throw a bunch of spray paint on it, and it really doesn't matter anyways. But if you're looking to do a multicolor print and you want the finish to turn out really nice, maybe 0.08 is good for you. Now, honestly, I don't really go below like a 0.12. 0.12, you're probably not going to be able to tell the difference with your eyes. I mean, honestly, does that look much different than a 0.08? Not really. Now you throw in some silk or some glitter into that filament, and you're definitely not going to see those layer lines. For most other things, a 0.2 is going to be just fine. And it's not going to be a drastic difference in time. Now I'm going to show you a trick, how to get that time down without sacrificing your surface quality. Alright, so now what do we do to get our time down? Well, one thing you can do is go to this quality tab, and I know I said let's not sacrifice any quality. You can see that's our layer height right there. We can change it to a different profile, and you can see that it changes the layer height there as well. So we don't want to really mess with that. But what else can we do? We can change the part's strength. And by strength, it's subjective. Strength comes from two parts: the number of walls in a print and its infill. There's a point where infill stops becoming a strengthening thing, and walls play a bigger part. So let's take a look. On a normal profile, you can see, let's go down, down, down in the benchy. You can see we have two walls, an orange one and a yellow one. And then we have all this infill in here. It's a pretty averagely strong part. However, if I wanted to make the part stronger, I can give it a couple more walls, and that will help when it's looking at those shear strengths. When you're trying to pull it or bend it apart, more walls helps because they're stacked one upon each other and can actually deflect some of that strength. Now you can see we've increased it by 2 minutes and a few more grams of filament, but that benchy hole is going to be unsinkable. You can hit an iceberg with it. Now, if I wanted to, I could also increase this infill to, say, 25, and it will give it a bit more strength in the compression. So if you were to take this and put it into a vise, all this infill is going to press against one another and try to resist that compression. So more infill combined with more walls is going to give you a stronger part. Now at a certain point, at about 45% infill, that's pretty much as strong as you're going to get on the infill. You can go ahead and say, let me go throw 78% infill in there, and it looks like it would be stronger, but really all you're doing is adding mass and weight to it and not really increasing the strength. If you want to know more about that, I suggest you go watch CNC Kitchen's video on what makes a stronger part, walls or infill. Shocker, walls have more of a impact on strength. So let's set this back to 15%, shall we? Now I said we can save some time, correct? Let's take a look at how we do that. So saving some time means you can either reduce walls or you can reduce infill. If it's just a prototype part that you need to dry fit, maybe you only want to do one wall. Saves you some time there. It's not going to be very strong, but if you're just going to toss the part away until you get it to fit right anyways, why waste more material, right? So we saved a bunch of material, but we didn't save a whole lot of time. Now here's how we save time. Perhaps you want to reduce the infill down to 5%. And you will save a tiny bit of time. Not a ton, but a tiny bit. So what you're really saving is the filament grams. Now you can not sacrifice so much strength by going down, and for some reason it cuts off on my screen, selecting support cubic material. What this does is it gives a sparse infill in most areas, and it gives a denser infill where the top layers meet. So it'll give it that support. You can see here it's the same level of 15% density, but in the areas that it's not really needed, it kind of stacks it at a 45-degree angle to kind of support that top layer. And you can see that underneath the benchy here. Let me go up to 25 so I can show you a better example. So you can see it's really just trying to support that. Now if we change this back to a grid infill, you're going to have significantly more. So really here, support cubic's going to save you some time. It's also going to save you some material. Now, on a benchy this small, it may not make a huge impact. So let's go ahead and scale this benchy up to 300%. And let's set these all back to default and see where we get when we slice the benchy. Alright, here we go. So we have 160 grams in about 5.5 hours. And that's at a pretty standard infill. Now watch what happens when I go to support cubic. Nothing else, just support cubic infill. I saved almost a half an hour on that benchy just by changing the infill. Now with support cubic, you can probably get away with 10%. Any lower and you might start having issues where surfaces meet the top and the infill. But now we're down to 4.5 hours and 128 grams. We've saved almost 50 grams of filament and about an hour off the printing, only by changing the infill. And we really aren't going to be reducing the strength of this part too much. Now let's look what happens when we jump up to a draft profile. So it will ask you if you've had these changes over here. Anytime you change profiles, it's going to ask you, do you want to transfer the changes that you've made, or do you want to keep the settings of the new profile? So it's a little backwards here. Old value means this is what the profile you're selecting has for this. The new value is the one that you've set currently. So you can check that here. We have it set at 10%. The default is 15. So I want to transfer these over so it doesn't change my settings here. Once we slice the plate again, watch how much time we're saving. We're down to 4 hours now. We've cut an hour and a half off this mega benchy by changing some infill and giving it draft settings. And for something like this, I'm probably going to throw spray paint on it, or maybe I like the look of the thicker layers, and I'm not really going to mind. So we've saved a bunch of time and a bunch of material. Now let me show you the opposite use case for when you'd want to have extra detail. Alright, so I've loaded up this little Elf Ranger miniature. It's a 28mm standard D&D miniature. And this is where you'd want to have a little bit more detail. You can see how organic this structure is. So we're just going to leave the same settings we had for the Mega Benchy. And we'll kind of take a look at what this looks like. Alright, you can see I've sliced it, but I've lost a lot of detail around his pelt here. I can't really make out the fingers. I mean, it still looks like a ranger, but it's a little hard to see. And on this one, the infill isn't really going to matter too much. He'll probably be pretty hollow. So let's go ahead and go back to the 0.2 layer height. Again, it's going to pop up and ask me, what do I want to do? Well, I want to just go with default settings for this. So I'm going to hit discard all my changes. We're going to slice them again. And you can see, interestingly enough, we got a little bit more detail out of the pelt here, a little more on the fingers, but we can do better. Let's go down to 0.12 fine layer height. And magically, you can see we have a lot more detail here in the pelt. Fingers become more pronounced. And if we really push this one, this would probably be the one case that I would go extra fine. You can see it basically buttery smoothed this miniature. The fingers are perfectly detailed. You've got a lot of great detail on the pelt. I mean, everything just looks phenomenal with this. So as a comparison, let me just jump back to the extra draft so you can quickly see. We lose a ton of detail here, but if you go to the extra fine, you save a bunch of detail. Now, of course, we're going to an hour just for this one figurine, versus if I just wanted to draft it and throw it on the table. Maybe it's just a minion or something, and it's going to get destroyed. We're probably going to only go down to 26 minutes. So, it's a trade-off. Now, like in the previous video, this piece requires some supports. You can see the overhangs where it's required. Now, I'm not going to actually go in and hand paint this stuff. I could, if I highlighted the overhang areas and I wanted to go in and paint individually. However, I want to see how well the supports work just by itself. So let's go over here to supports. We'll enable supports, and let's go to normal, or let's go to tree auto here. Ooh, where did my... There it goes. Interesting. So we're going to go tree auto and just see kind of how it wants to place these supports. I usually do this first to see what it's finding, and then I can go back and fine tune it. So I think this did a pretty fantastic job. It supported the arms, it supported his little pelt area, and his cape over here. I don't really see anything else. Now, there's a little bit in here, but I could probably pluck that out without too much issue. And now you can see we've got a nice supported structure. Now this is the case, like I said, when you'd want to use tree supports on an organic model to help support these areas that are kind of hard to get to. Versus if you went to normal auto supports, it's probably going to make a mess. There's a lot more supports in there, a lot more to pluck out, a lot harder to get to, and as you pull this support out, notice how it wraps around that actual bow and arrow there. You might actually break that when you try to pull these out. So in this case, the tree supports are the better option because it tries to avoid that bow and arrow there. You can see it's on the front end, but it doesn't really wrap around it and hold it in there. So there's some options on how to speed up your print, how to get better quality, or if you don't really mind the quality, you can speed it up even faster with a higher layer height. And then a use case for these organic tree supports. Alright, one thing that I would like to leave you with as well is how to use a raft or a brim. Now, I prefer a brim for small objects, and that's under this Others tab here. So you can see, in relation to the print bed, there's really not a whole lot going on here to stick it to the bed. And if we look at the preview, in fact, if you scale all the way down, you can see the really only contact area is this outer rim. The rest is going to be some supports underneath here, just to support that base until it gets up to that top layer. So there's not much holding it to the print bed. However, if I say I want a brim, and I can say outer brim only, there's other things like inner brim, outer and inner brim. Those are special use cases. Select outer brim only, and let's see what the default does. You can see now there's this blue line, and that blue line is the brim. what it's doing is it's adding some other support out here. It's trying to hold down that thin contact area and hold it to the plate. That way, if it's moving fast or if it decides to warp up, it doesn't pop right off the plate. So if you're having issues with warping or adhesion, a brim may help you out. Now you can try and go super overkill with this and have a 20 millimeter brim. I don't think that's necessary, but the option's there. I think anything over 8 millimeters is a little bit overkill and should help with any warping or adhesion problems that you have. There's also a thing called a skirt. So let's disable the brim and let's add a couple of skirt lines. You're probably familiar with this if you've seen a Prusa printer. The Prusa likes to put a skirt around there, and that's more used for if you have a bunch of really, really small pieces on the bed. The skirt will prime the nozzle before it moves to one of these small pieces to ensure that there's no issues depositing the filament. What that looks like is, let's go ahead and turn off support. Let's scale this down maybe 30%. Now we have a really tiny part, right? Let's go ahead and clone it. Let's give it a couple clones on the bed. Let's arrange them. And then let's slice them. You can see here what it's going to do on the first layer is it's going to print that skirt and then move over here and begin printing this small area. If I did not have this skirt active, let's put it to 0. That first layer would look a lot more like this. Your first deposit is going to be right here. The issue you may run into is the first portion of this line may not come out until about a quarter of the way through because it's building pressure in the nozzle. The skirt helps it to build that pressure before it starts laying down your print and ensures you have a full, completed footprint. So it's a little tidbit, a little tip that I gave you here in this video. Alright, so in this one we've kind of went through some quality settings, some speed settings, infill, and how to make your parts stronger, faster, or more detailed. And we also looked at a really good use case for organic tree supports and looked at using brims and possibly skirts on those hard to stick or peeling up parts. In the next video, we're going to go ahead and look at what it looks like on the device tab. We're going to run through a bunch of these settings. I know it looks intimidating, but I promise you, stick with me. We're going to get through it, and we're going to simplify it so you're going to be ready for multicolor printing. That's right, that big thing that everybody wants to do, we're going to do it in the next video. So stick around, and we'll see you on the next one. Bye now.